The dark truth about Dyson spheres: they're not for energy. The star dimmed mid-sentence. Instruments froze. Then a thin, surgical ribbon of light slid across a moon and peeled its crust like an orange rind. This wasn't an energy project. It was target practice. We're told Dyson swarms mean utopia, oceans of clean power and end to scarcity. But swarms don't just collect energy, they steer it. And anything you can steer, you can aim. That's where civilizations live or die. Tonight we follow a line from the 1960s to now. Freeman Dyson's paper, Infrared Surveys Like WISE in 2009, Tabby's star in 2015, and ask a hard question. Are Dyson spheres about energy or control? The dream we were sold. We grew up on the postcard, a glittering halo around a star, a Type II civilization drinking sunlight forever. The pitch was elegant: harvest a fraction of a star and poverty becomes a museum piece. But the postcard leaves out the fine print. Dyson's 1960 paper wasn't a blueprint, it was a detection argument. If anyone builds industry at stellar scale, they'll glow in the infrared. He gave astronomers a target, not engineers a shopping list. And right away, one correction: nobody builds a rigid Dyson sphere. A solid shell is dynamically unstable, hilariously beyond material strength, and a thermal disaster. The workable idea is a Dyson swarm, a cloud of independent mirrors, collectors, habitats, and transmitters sharing orbits and trading phase like a choreographed flock. Rings, inclined rings, drifting shells. Control, not enclosure. The hopeful part is true. The star gives more power than a civilization can use. The hard part is moving that power where and when it matters. That's not a collection problem, it's a logistics problem. You harvest photons on one side of a system, and you have to deliver gigawatts, safely and precisely, to a retina or a factory far away. Every conversion shaves efficiency. Every kilometer spreads your beam unless you fight diffraction with bigger apertures and tighter coherence. The collection line on the spreadsheet looks easy. The transmission budget eats you alive. Now here's the pivot. The very skills that make a grid reliable are the skills that make a beam dangerous. A phased array that paints a retina gently is a phased array that can tighten its lobe and spike irradiance. The software doesn't care about your ethics. It cares about phase error, jitter, and pointing. As you drive those down, you drift from power quality to strike quality, and no one has to announce a doctrine change for it to happen. Why swarms, not shells? Stability and materials, sure, but also governance. A swarm is modular. You can add, remove, and reassign nodes. You can fold in imaging, comms, and propulsion without rebuilding the whole thing. You can phase lock a subset for high precision and keep the rest on wide, safe power modes. That granularity is a dream for grid resilience, and a dream for fine-grained control. Let's talk incentives. Big infrastructure gets built for jobs, growth, climate, prestige. Dual use sounds responsible, but it's slippery. The first time a grid operator routes excess to stabilize a blackout 2 planets over, they've proven they can deny that power too. The first time an operator tightens a spot through a storm, they've demonstrated a thermal weapon in miniature. Intent isn't required. Convenience is. Consider the physics knobs. Aperture sets beam spread, bigger baselines, narrower beams. Wavelength sets coupling, microwaves love water and dielectrics. Near IR heats industrial skins, UV and X-ray ablate and ionize. Time sets temperament, continuous warms and warps, pulses crack and spall. The better you get at efficiency, the closer you creep to regimes where steering becomes aiming. Safety promises arrive on schedule. Interlocks, caps, geofences. Advocates say beams will be diffuse at planetary scales and dumps will land in heat sinks. That holds until the network fails weirdly. Faults cascade. A mies-tagged mode, a skewed ephemeris, a malicious update, and a maintenance test pattern looks like a strike. Complex systems fail in patterns no one rehearsed. Meanwhile, the culture around the tech starts to tell on itself. Look at the 1980s for GPS. Civilian tool, military spine. Look at the 2010s for drones. Delivery dreams, battlefield realities. Flow control systems. Water, traffic, electrons pick up leverage because control is value agnostic. A Dyson swarm is control at stellar scale. The line between optimize coupling and maximize absorption at target is a settings file. Here's a human moment. Asha, a junior engineer on a power beaming demo, watched a stratospheric balloon's rectenna flicker under a passing storm. She tightened the array's phase, nudged wavelength to band the rain loved, and the readouts climbed. Her team cheered. Later, she replayed the logs and saw the thermal spike on the balloon's skin. Same algorithm, same joy of precision. Asha wrote one note: "If this console existed in a crisis, I wouldn't know what I was doing until after." That's the dream's shadow. The quiet truth under the postcard: once you can steer it, you can aim it. Not because you add a red button, but because the physics rewards the same tricks for kindness and harm. The story we were sold promised abundance. The story we need weighs abundance against aim, discipline against drift, and asks who holds phase authority and who can't. Concentration physics, turning a sun into a scalpel. To turn sunlight into intent, you move from radiance, what the star throws in all directions, to irradiance, the power a patch of matter actually feels. The space between those words is geometry and discipline. You don't pour a star, you shape it. Aperture is the first lever. Diffraction sets the math. Divergence scales with wavelength over diameter. Make the effective mirror larger and the beam gets tighter. A ring 1,000 kilometers across acts like a lens you never built, pulling starlight into a main lobe instead of a flashlight smear. Slide the wavelength down, microwaves to near IR, and the lobe sharpens further, but cleanliness, cooling, and polish get unforgiving. Coherence is the second lever. A single mirror reflects. A swarm that agrees on phase interferes on purpose. Phase lock 1,000,000 elements and you get a synthetic optic. A primary lobe where you want power, side lobes shoved into patterns you design, and grating lobes suppressed by dithered spacing. The budget turns human, phase error, jitter, thermal drift. Kill those and the beam stops being polite. Timing is the third lever and it bites. Elements orbit. Light takes time. Your control stack must predict path lengths and rephase faster than the spot walks off. That means laser metrology across astronomical baselines, clocks that hold picoseconds, star trackers that don't blink. It feels like astronomy, but the output is policy. A grid calls it power quality. A strategist calls it strike stability. Diffraction doesn't go away even when you're perfect. At interplanetary ranges, a moderate baseline still paints a footprint hundreds of meters across. That's plenty for rectennas, it's sloppy for precision damage. Stretch the baseline toward planetary scale and footprints drop. Tens of meters, then less. The slider appears. Wide and gentle for grids, narrow and surgical for coercion. Physics gives you the option. Doctrine decides where you stop. Time structure sets temperament. Continuous beams heat and soften. They boil water, puff atmospheres, and push structures past yield. Pulsed beams dump energy faster than heat can run, thermal shock, spall, ablation. Low duty cycle with high peak power cracks things. High duty cycle with moderate peaks cooks them. A swarm flips between temperaments by time-slicing phase plans. Same hardware, different cadence, different failure mode. Coupling is where wavelengths meet matter. Microwaves soak water and many dielectrics, great for atmosphere, soil, and fluids. Near-IR couples well to paints, polymers, and industrial skins. UV and soft X-ray ionize and ablate, turning surfaces to plasma that then drinks the rest. Pick the band and the target picks the wound. Blister, crack, peel, plume. Side lobes become ethics. A sloppy array sprinkles the sky with unintended hot spots. For power beaming, that's wasted efficiency and nuisance heating. For a fence, it's collateral. So you dither element positions to kill grating lobes, overbuild radiators to tame thermal phase noise, and hold phase codes that don't ring in nearby bands. The cleaner your lobe, the smaller your footprint, and the bigger your responsibility. Latency is the trap. At light speed, deliberate means delayed. Minutes across a system, years across stars, targets move. Air breathes, defenders deploy. You compensate with prediction and dwell. For power, rectennas don't dodge. For weapons, you merge sensing and shooting. The leading edge of your pulse acts like LiDAR, speckle, phase, refractive wiggle. Microcorrections ride on the tail. It's guidance by self-illumination, but only within the jitter the lag will tolerate. There's a brute force path that doesn't care about knife edges. Redirect a small percent of a star onto a world for days. You don't need micron spots. You need persistence. Ice melts. Jet streams reorganize. Storm factories spin up. Subtlety yields to climate-scale attrition. Concentration isn't only a scalpel, it's also a press. Nested imaging is the ugly hack for distance. Instead of one impossible aperture, you change stages. A near-star array forms an intermediate image, tightening the beam before it walks the void. A mid-course cluster grabs that lobe and sharpens it again. The last stage does final focus. Each link is manageable. The chain is terrifying. It trades single machine magic for choreography. Thermal management telegraphs what you're doing. Power modes run smooth, steady radiator glow and mid-IR manageable gradients. Weaponized schedules pulse. Radiators swing hot-cold as clusters cohere and decohere. From far off, it looks like a heartbeat. You can try to hide it, aim radiators into crowded dust bands, run colder with oversized area, feed waste into veils that re-radiate broad and dim. You pay in mass, complexity, and recovery time. Here, S where optimize slides. The control verb maximize coupling is identical whether you're helping a ship or hurting a satellite. Same lookup tables for absorptivity. Same phase stability to hold a spot on a scene. The interface doesn't announce a moral pivot. It shows green bars and tighter numbers. The line between stewardship and leverage becomes a slider you can move with a fingertip. So the scalpel isn't in the mirror, it's in the math. Aperture narrows, wavelength chooses wounds, coherence carves, and time decides whether the cut is a slice or a bruise. Once a swarm can hold phase like that, intent becomes a settings file, and the safest setting is the one you can prove you can't leave without a ritual. The architecture that decides intent. Architecture is doctrine cast in metal. Topology is your first confession. A single equatorial ring is training wheels, dense, serviceable, and obvious. It beams well inside its plane but struggles above or below it. Add inclined rings and the lattice starts to cage the star, opening geometry for cross-plane phasing. Push density and you approach a shell in appearance, still a swarm, but thick enough to synthesize huge apertures. The denser and more multi-plane your cloud, the easier it becomes to paint precise lobes anywhere you want. That's power distribution if you're kind. It's targeting if you're not. Statites change the game. Instead of orbiting, they hover, sails balancing gravity with photon pressure. Lock them into polar hangs in high latitudes and you get baselines that stay put for months. Precision loves that. So does coercion. A statite lattice is stubborn, hard to nudge, harder to knock down without collateral. The bill is mass, control, and maintenance. Torn sails, aging coatings, and a control plane that never sleeps because every square meter needs shepherding. Control hierarchy is where intent condenses. Centralized brains make clean grids, one scheduler, global phase, graceful handovers. They also create a single switch that can sharpen a beam in seconds. Federated clusters, local quorum, global intent signals, are messier. They buy resilience and add time constants that resist snap retasking. If your architecture can flip phase authority across 100,000 nodes faster than your auditors can blink, you've built a strike engine whether you plan to or not. Autonomy creeps in because light lag punishes hesitation. Healthy swarms push decision-making down. Local clusters agree on phase and health, escalate only intent. Point here, dwell this long, abort on X that's robust for power and brittle for ethics. If abort on X drifts or an identifier collides with a hospital's tag, the cluster obeys its rules at machine speed. Humans read the log after. APIs leak doctrine. The verbs are shared: acquire, track, maximize, coupling, maintain, lock, retask. Grid operators need them, so do strategists. You can rename modes wide, medium, tight, and fence them with authentication, but the verbs remain. The first time tight gets a late-night exception to punch through a storm. Your governance learned a shortcut. Exceptions ossify into defaults. Thermal management makes posture visible. Grid mode breathes slow. Broad radiators glowing steady in mid-infrared, predictable gradients. Weaponized cadence pulses. Asynchronous hot-cold swings as clusters cohere and decohere. Directional thermal plumes when waste is dumped off-axis to hide. Camouflage exists. Cooler radiators. Dust veils that smear spectra into the galaxy's thermal carpet. Louvers that beam heat into crowded bands. Every trick costs efficiency and recovery time. If your architecture pays that price, it's telling you it expects to be watched. Failure philosophy is a fork you can see from space. Fail-safe designs default to diffuse, lose phase, widen, lose time sync, drop output, lose authentication, fall to maintenance patterns that cannot cohere. Fail deadly defaults to last known good, hold lock until an explicit cancel arrives. Engineers justify it with jamming fears and credible deterrents. Citizens live under a hair trigger. The spec you write today becomes someone else's doctrine. Mesh resilience is double-edged. Redundant links, voting logic, and peer healing make uptime beautiful and make accountability murky. If 3 controllers can authorize a mode change and the network stitches them together, who owns the crater when a firmware push and a test overlap? Traceability requires friction. Signed intents, irreversible logs, and physical seals on high-precision lanes. Efficiency hates those. Efficiency usually wins. Scheduler signatures betray motive. Power beaming favors slow ramps, predictable handovers, and blacklists that carve stable no-beam zones. Strike posture rewards snap retasks, hard stops, and micro-geofences. A city block precision that screams targeting whether or not you fire. If your scheduler can jump baselines across inclinations in a heartbeat, you've normalized behavior that makes neighbors twitch. Human in the loop is a promise physics breaks. At swarm scale, humans approve policies, not shots. The loop collapses into automation because metrology runs at picoseconds and windows are tight. The dashboard shows green. Optimized coupling makes sense when the rectina is yours. It's indistinguishable from malice when the identifier is wrong. The only durable break is architectural, modes that can't sharpen without a ritualized, time-delayed unlock. Storage and spares shape tempo, distribute propellant and mirror stockpiles, and you can reconfigure fast. That's great for grid resilience and perfect for mobilization. Replacement rates define stamina. A supply chain that can outpace micrometeoroids under peace can surge under fear. Logistics becomes latent doctrine. Someone will notice and write plans that assume it. Deception is part of the blueprint if you let it be. Decoy radiators that run constant load to hide pulses elsewhere. Spectral camouflage that pushes heat into bands crowded by zodiacal light. False training schedules that feed rivals. Calendars while real retask runs randomized and cold. A grid that practices deception has already crossed a line. It's optimizing for surviving accusation, not for being understood. Ashas saw the architectural drift firsthand when her team upgraded the control stack. Central scheduler, then federated backups, then a fast lane for emergency retask. In test, the fast lane hit marks that made investors grin. In audit, she asked what emergency meant and who could declare it. No one had an answer the hardware could enforce. The spec said human approval required. The code said token present. Tokens multiply. Doctrine hardens in small choices. Multiplane density, statite lattices, low latency autonomy, snap retask, cooler radiators pointed away from prying eyes. None of those scream weapon. Together, they narrow options until aiming is the lowest friction move. If you want a swarm that warms worlds, you build mess on purpose. Slower handovers, caps in hardware, split keys across rivals, and delays you can't bypass without lighting up the sky. If you don't, your architecture will decide for you. Strategy 101. Power projection at light speed. Once a swarm can hold phase, the fight stops being hardware and starts being timing. A beam leaves now, lands later. Minutes across a system, years across stars. Strategy lives in that lag, and every doctrine choice is about who reads the calendar better. Inside a system, light time is a nuisance. You predict orbits, track burns, and dwell long enough to average out jitter. Across interstellar distances, prediction explodes. Planets swing behind stars. Atmospheres breathe in seasons you've never felt. Civilizations change shift schedules while your pulse is still crossing the dark. You aren't aiming at a location. You're aiming at a habit you hope still exists when the energy arrives. So you build prediction like navies build fire control. Layer gravitational models with behavior. Don't just track rectinas. Track maintenance windows, market rhythms, religious holidays. If a grid dips every local morning on the 19th day, the vulnerable hour isn't a coordinate, it's a ritual. Power projection at light speed means aiming at routines. Uncertainty breeds first strike incentives. If you suspect their swarm will concentrate sooner than you can defend, a preemptive shot looks rational. You don't melt cities. You blind phase references, cook timing beacons, scorch calibration stars they rely on. But they run the same calculus. Under lag, both sides think going first is safer. The sky gets hair triggers you can't hear until they trip. Deterrence tries to sit on those triggers. To deter with beams, you show reach and retask. You demonstrate schedule discipline, surgical burns on inert targets, public windows you hit to the second. You make compellence real. Use persistent, precise heating to force actions, not just to stop them. Compellence is harder. It needs presence and patience under lag. It needs proof you'll keep the beam when they try to ride it out. Signaling becomes choreography. Smooth ramps and graceful handovers read like grid behavior. Snap retasks across inclinations read like a strike posture. You can calm markets or jolt ministries by adjusting cadence. The credible threat isn't loud, it's specific. Name a window, a location, a cost. Leave just enough fog that they don't game you, just enough clarity that they don't gamble wrong. Defense exploits physics on the receiving end. Ablative layers buy time, turning beam into vapor and noise. Plasma mirrors and magnetic sails reflect or defocus certain bands, forcing a fence to switch wavelengths and lose coupling. Reflective decoys bloom in numbers, splitting the attackers dwell across ghosts while the real rectina shifts address. No shield beats a star. Shields by minutes, hours, days, enough to roll, hide, or answer. Atmosphere is both ally and betrayer. Some bands smear and absorb, spreading heat. Others run clean and invite damage. Defenders seed aerosols tuned to the attack band, pushing the fight into less efficient wavelengths. Offense timeshares around that, flicking between bands, riding polarization tricks, surfing weather like a weapon. From the ground, it looks like a forecast. From orbit, it's a duel. Logistics decides who's still dueling next year. Mirrors pit, coatings fog, electronics bake. A Sirius projector maintains replacement pipelines at steady and surge states. If you can replace 2% of your array yearly at peace and 20% under stress, you outlast a bigger but brittle rival. Attrition isn't dramatic, it's a sandblaster. The side that keeps quorum wins. Kill chains collapse under lag unless you merge sensing and shooting. Detect, decide, deliver becomes one operation when the leading edge of your pulse acts like LiDAR, reading speckle, phase, and refractive shimmy, while the trailing energy rides the microcorrections. Inside a system, you can close that loop in real time. Across stars, you fake it with calendars, ensembles of predicted windows, bracketing shots that hedge against drift. Windowed aggression is how you multiply limited power. You shoot during eclipses that hide your glint. You aim at seasonal thinnings in their air at your chosen band. You schedule pulses when meteor streams force their statites to roll protection, pushing their radiators near limits. You don't add energy, you add timing. The same wattage hurts more when the target must blink. Counterintel turns doctrine into misdirection. Fake transits teach enemy models to chase planets that aren't there. Decoy swarms run grid signatures on public schedules while the real arrays operate cold, randomized, and off-axis. Heat mirroring points waste into blind regions, behind bright clouds, under zodiacal glare, then dumps when your sensors saturate during stellar flares. Offense answers with diversity, multiband watchers that don't blink together, off-ecliptic sentinels that see what glare hides. The most dangerous errors are human patterns you didn't realize you taught, rehearsals at the same hour, maintenance on the same day, exceptions that always favor one corridor. Asha learned that when her team's emergency lane got tested every Friday at noon. A rival wouldn't need a spy, they'd need a calendar. All of this strains governance. Treaties that cap coherent aperture, mandate warm-up durations, and ban retasks faster than agreed thresholds turn fear into numbers instruments can check. Telemetry and reciprocity keep crises from guessing games, but enforcement is culture. If you've trained for snap retask because it feels elegant, you'll break your own caps when the grid aches. So power projection at light speed is a discipline of habits. Offense writes calendars. Defense erases them. The side that forces the other to schedule first wins the clock. The side that loves breaks more than elegance gets to keep a sky that isn't full of hair-trigger rituals waiting to fire. The Fermi Paradox Reframed. Under a beam-dominant sky, silence isn't mysterious, it's policy. If a swarm can turn a star into a scalpel, then broadcasting becomes a liability. The old question, where is everybody, turns into a filter. The loud get mapped, the mapped get modeled, the mode-led gets scheduled. Once your maintenance windows fit someone else's fire control, your story becomes an entry in their training log. Think of the dark forest as operating doctrine, not poetry. In a forest where every rustle could be a hunter, you don't sing. You move at dawn and dusk. You mask your heat and time your fires for fog. In the sky, that means tight beam laser comm instead of broadcast, power beaming that looks like thermal weather, and waste heat pushed into bands that drown in dust. Hello, we're here becomes nothing to see. Why would a bright civilization vanish? Because brightness isn't just photons, it's patterns. A grid breathes with days and seasons. A retina inhales and exhales on schedules. Shipyards flare with maintenance cycles. Patterns create prediction. Prediction turns energy into coercion. If your opponent can forecast the hour your shield must roll back to vent, they don't need a planet killer. They need a window. So signature management becomes survival. You randomize duty cycles. You smear baselines. You bury industry in noise that tracks stellar weather instead of market demand. You discipline lasers and radar so side lobes don't betray geometry. You accept inefficiency as a tax. Markets hate that. Bureaucracies hate that. But the dark forest rewards cultures that love breaks more than elegance. There's a timeline here. Early-stage civs leak like sieves. Broadband radio in the 1940s, radar in the 1950s, TV in the 1960s through the 1990s. Then the curve bends. The 2000s and 2010s shift to fiber, narrowband, and point-to-point. The sky gets quieter not because curiosity died, but because efficiency and security aligned with stealth. Under beam doctrine, that drift isn't cultural, it's adaptive. Waste heat is the part you can't hide, only reshape. Freeman Dyson's 196 suggestion was simple: look for mid-infrared excess where a star's light should be. Surveys like WISE, launched in 2009, did exactly that. We found lots of dust, debris disks, red giants, shrapnel from shattered worlds, but not many clean, hot technosignatures. That narrows possibilities. Either megastructures are rare, sloppy ones are rare, or careful ones run cold and directionally, hiding under the galaxy's thermal carpet. Tabby's star in 2015 was a lesson in humility. KIC 8,462,852 dipped irregularly by tens of percent, wild, intriguing, and very unplanet-like. A megastructure rumor sprinted around the world. The mid-IR didn't scream industry. Dust kept winning in peer review. But the doctrine takeaway was no swarms. It was odd light curves aren't enough. If a civilization runs cold, spreads heat over absurd area, or beams waste away from our line of sight, We'll need behavior, not brightness, to catch them. Behavior is doctrine in motion. A grid-first swarm breathes like a utility, smooth, seasonal, anchored to orbital geometry. A weapon-disciplined posture pulses and pivots, clusters warming and chilling in asynchronous beats that line up with plausible retask windows. You don't just ask, is there excess heat? You ask, does the heat act like logistics or like drills? Even in a dark forest, people rehearse. SETI changes under that light. Old school listening chased messages. New school listening hunts for work. Technosignatures become industrial rhythms. Thermal cadences, unnatural polarization, spectral lines from exotic chemistry, light curves that refuse astrophysical baselines. We build patience into instruments and learn to read habit. We assume intentional quiet until the data argues otherwise. There's an ethical knife edge. Curiosity pushes us to shout. Survival nudges us to whisper. One move risks inviting a stranger to write our schedule. The other risks never meeting anyone. The restraint isn't cowardice. It's respect for a universe where steering power is easy and good faith is unverified. If we transmit, we should do it like surgeons, gloves on, from relays far from home, with content that tests comprehension without handing over a map. Asha felt that tension when her team proposed a beacon test piggybacked on a power demo. The physics looked clean, the PR gleamed, and the lab could measure round-trip response with exquisite clocks. She traced the side lobes, the timing, the cadence, and saw how a rival could fold it into a model of their scheduler. The thrill of being seen graded against the certainty of being timed. She pushed for a whisper instead, a one-off off-axis during solar glare. The applause was smaller. The sleep was better. So the paradox reframes itself. Maybe the galaxy isn't empty. Maybe it's disciplined. The survivors aren't the brightest. They're the most legible to themselves and the least legible to strangers. They built swarms that hum, not sing. They capped phase authority in hardware. They published heat ledgers their rivals could read. They taught engineers that optimized coupling is policy, not just math. In that forest, silence isn't absence, it's culture. And if that's true, then our best chance at meeting someone isn't shouting. It's learning to read the quiet, so we don't mistake drills for weather, or weather for a threat, and proving with our own behavior that we can be understood without being modeled into a window. Waste heat, the signature you can't hide. You can hide talk. You can disguise light. You can't cheat entropy. Every joule a swarm roots ends up as heat somewhere, and that somewhere glows usually in the mid-infrared, whether you like it or not. Thermodynamics isn't a guideline. It's the invoice you pay continuously. Start simple. Collectors drink starlight. Some of that energy becomes useful work, power beaming, propulsion, chemistry. The rest must be dumped at a lower temperature across radiators. Temperature sets color. Hot radiators shine shorter, cold radiators longer. You can spread heat over ridiculous area to run colder and dimmer per square meter, but the integrated flux still adds up. The game becomes spectral landscaping, not erasure. This is where Dyson's 1960 point bites. He argued we should look for mid-IR excess, stars that appear too bright in heat for their class. WISE, launched in 2009, gave us that map. The sky lit up with imposters, debris disks, red giants, carbon soot, shattered comets. Sloppy megastructures would have popped. They didn't. That doesn't kill the idea, it narrows it. If disciplined swarms exist, they likely run cold, directional, and camouflaged under the galaxy's thermal clutter. Camouflage comes in flavors. Angle radiators so their brightest emission points away from crowded lines of sight. Tune emissivity so photons land in bands polluted by zodiacal dust and molecular clouds. Wrap activity in dust veils that absorb hot waste and re-radiate it cooler and broader. Or run cold. Vast thin-film radiators that sink temperature, pushing photons into longer wavelengths where our surveys are poorer and the sky is noisy. All of this works. All of it costs mass, complexity, recovery time, and efficiency. Heat has a second truth. It carries rhythm. A grid-first posture breathes like a utility, slow ramps, seasonal modulation, diurnal hints, smooth buffers. A weapon-disciplined posture pulses. Clusters warm and chill asynchronously as they cohere, dwell, and release. Radiator fields beat out patterns, hot, cold, hot, in cadences that line up with plausible retask windows rather than with day-night cycles. From far away, it looks like a heartbeat with intent. So the observational problem stops being how bright and becomes how does it behave. You watch for correlated transients across inclinations, 3 mirror groups in different planes warming in sequence, then cooling in the inverse order with delays that match light time to a particular region. You check crossband, a mid-IR flare here, a near-IR blush as coatings heat, a microwave whisper as control links spike. One event is noise. A schedule that survives seasons is doctrine. Nature fakes pieces of this. Young stars flicker as they feed, dust clumps drift, giants burp. That's why you stack constraints. Cross-match spectral type age dust maps proper motion. Throw out known variables. Model parallax precisely so you aren't fooled by blended sources. What's left aren't aliens. They're dossiers, candidates with behavior inconsistent with astrophysical baselines, pinned for long, patient scrutiny. There's a catch defenders exploit: heat mirroring. You can move waste off-axis, dumping into directions where you're blind, behind bright nebulae, under the ecliptic glare, during solar events that saturate sensors. Decoy radiators can run constant load, singing a lullaby while weapon clusters dump into colder, louvered fields pointing away. Breaking that trick requires timing diversity, watchers off the ecliptic, sensors that don't blink together, and analysis keyed to stellar weather so you notice antiphase blips when flares wash the sky. Cold running has tactical trade-offs. Cooler radiators mean slower recovery from peaks. If you dump a hard dwell, your thermal mass climbs, your next shot waits, your footprint grows. Extreme stealth stretches operations on purpose. That's fine for grids. It's costly for fast coercion. So if you see a system that's extremely cold and maddeningly steady, you may be looking at either monastic restraint or a decoy. The tell is cadence. Do small, correlated ripples ride the steadiness at intervals that make sense for phase rehearsal. Asha learned to read that rhythm the hard way. Her team tested safe modes on a lunar night, low output, broad beams. The radiators looked flat in mid-IR, a line so boring you deframe it. Then she overlaid 3 weeks and saw tiny sawteeth stepping across clusters with a 17-minute offset. Their schedulers retasked granularity. It wasn't bright. It was regular. She flagged it not as a hazard, but as a habit. If she could see it, so could anyone writing a calendar. On our side, transparency helps friends and unnerves rivals for the right reasons. Publish heat ledgers, radiator states, warm-up times, dwell caps, with hour-scale delay. Certify drills with neutral monitors who can see your cadence and confirm your caps. That doesn't disarm you. It proves you can't accidentally sharpen past treaty limits. It also teaches analysts what benign industry looks like, so their models don't jump at weather. For SETI, waste heat becomes the safest conversation. We shouldn't expect friendly radio. We should expect work that leaks. Build instruments that watch behavior over years. Favor mid-IR cadence analysis, not just single epoch brightness. Cross-correlate across bands to catch control layer hiccups. Rank candidates by logistics-like versus drill-like signatures, then stare longer at the latter quietly. And remember the moral of heat. It tattles on doctrine. You can hide messages and shapes. You can't hide recovery time. If your culture chose breaks, caps in hardware, slow handovers, messy federated control, your radiators will hum, not strobe. If your culture loves elegance and snap retask, your heat will keep a beat. In a forest that punishes patterns, the safest thing your swarm can be is inefficient, legible to friends and boring to everyone else. The timing problem, attacking across years. Across a solar system, a miscalculation costs minutes. Across stars, it costs you the war. Light takes years, orbits process, atmospheres breathe, people change their routines. By the time your beam arrives, night may have rolled under clouds, a shield might be venting heat, or the factory you aimed at could be dark for a holiday you didn't model. The problem isn't can you hit. It's can you predict the exact moment hitting matters. Interstellar timing errors start microscopic arcseconds in a telescope and balloon into hundreds of kilometers at arrival. Planets don't carve perfect ellipses. They wobble to the tugs of neighbors and moons and to mass shifts inside their mantles. Air density drifts with seasons. Refraction swings your spot. Then culture adds noise. Station keeping burns off schedule, surprise drills, policy shifts that move maintenance windows. Prediction drift is physics plus behavior. You need both models, and the second one is slipperier. So you build reconnaissance that stretches across years. Parallax pins distance. Transit photometry turns dips into ephemerides with uncertainties you can propagate to specific days. Industrial light curves do the cultural work. Grids breathe, rectennas inhale, shipyards flare on rhythms that feel human. A decade of that becomes a calendar. Not Tuesday at noon, but every 19 days at local dawn, a shield rolls back and exposes a lattice for precisely 43 minutes. Now your target isn't a place, it's a moment. The kill chain breaks where time breaks. Detect, decide, deliver sounds clean until you fold in light lag. You detect what happened years ago. You decide tomorrow with a model that admits its ignorance. You deliver into a future where they might know you exist, even if they don't know you fired. Every stage has to carry uncertainty forward, not hide it with false precision. A sloppy model gives confidence you didn't earn. A timid model never fires at all. Windowed aggression is how you cheat the lag. You don't aim at a planet in general. You aim at vulnerability cycles, eclipses that force arrays to pivot, seasonal thinnings that lower absorption at your chosen band, transit seasons when the target crosses its star and your beam can hide in glare while their sensors lose dynamic range, meteor streams that make statites roll shields and heat radiators to their limits. You bring the same energy. Timing multiplies it. Defenders do the same math. They build counter calendars. Dust lofted in fake transits trains your model to chase ghosts. Decoy swarms rehearse public grid cycles while the real array runs randomized and cold. Heat mirroring points waste into your blind spots behind bright molecular clouds under zodiacal glare, and then pulses hard during stellar flares when your detectors saturate. They move maintenance windows unpredictably, even at cost. Their goal isn't efficiency. It's survivable ambiguity. The last meter problem makes or breaks precision. A razor beam still misses seams if turbulence and refraction wander in those final milliseconds. Inside a system, you close the loop by letting the leading edge of your pulse act like LiDAR, reading speckle, phase, and shimmer off the target's skin, and riding microcorrections on the tail. Across stars, you can't. Your correction lands years late. So you hedge with ensembles, staggered pulses aimed at the center and at the edges of your predicted window, plus a reserve shot that costs power but buys probability mass across outcomes. People sit at the core of drift. Bureaucracies shift shifts. Holidays slide. A reformer cancels a parade that would have dimmed the grid when you needed it dark. You hedge there too. You don't bet on one habit. You bet on clusters of habits that are harder to change. Thermal cycles set by orbit, eclipse chains locked by physics, maintenance tasks tied to exposure that no one can fake for long without paying dearly. Here's where doctrine leaks. Offense writes calendars. Defense erases them. The side that forces the other to schedule first, by threat, by rumor, by an engineered crisis that pulls a shield out of sequence, wins the clock. Asha watched that dynamic when a rival announced an unexpected audit of their own array. Her team almost mirrored the publicity with a demo. She killed the press release. Silence preserved their timing. Meanwhile, nearer fights demand different tools. Inside your system, you can refresh ephemerides with lasercom pings, watch a hinge glint and fire during the first flash of a rolling louver. Time compresses to seconds again. That's why credible interstellar postures usually pair with local discipline. Long geometry planning abroad, snap precision at home. The same swarm flips roles by reassigning baselines, wide for far, tight for near, without changing hardware. Attrition erodes timing just as surely as error bars do. Mirrors pit, coatings fog, clocks wander, recovery time lengthens, windows slip. If your replacement pipeline lags, your calendar wobbles where it used to sing. Rivals will see that in your heat and cadence and right moves that exploit the sag. Timing isn't only math, it's logistics. In the end, the timing problem isn't a footnote, it's the fight. Plans become weather reports stitched to sociology. Defense becomes noise management stitched to honesty about what you can't fake. Across years, the decisive move isn't more power. It's a better calendar, and the restraint to keep yours illegible while you read theirs. Inner system weaponization, the local fight. Closer in, timing stops being theory and starts being muscle memory. Light time drops to seconds. A mies-tagged mode isn't a history lesson. It's a scorch mark you can visit by lunchtime. You don't need a galaxy-spanning lattice. You need a few ruthless choices, a tight control stack, and a supply chain that doesn't blink. Start with climate hardware turned inside out. We talk about L1 sunshades to cool Earth by shaving insulation 1%. Flip the sign and you've built a heat lens. A 1% increase doesn't read like a weapon on a chart, but hold that extra sunlight over a breadbasket for 4 days and see what happens. Crops stress early. Reservoirs slump. Grids sag as air conditioners fight entropy. The same predictive models that smooth weather shocks become targeting software when you stop compensating and start dwelling. The moon becomes a platform the second you stop treating it like scenery. Airless, stable, close, exactly what phase transmitters crave. Lay kilometer-scale solar fields on the far side, tie them together with optical clocks and phase lock them. Now you can flood cislunar space with microwaves for power, then squeeze lobe width and skim tight beams along Earth's limb. Done right, it looks like grid resilience. Done fast, it can blind a telescope, cook a booster's cryo line on ascent, or push a rogue depot out of station-keeping margins. Mercury is the factory. Sunlight 4 times stronger, a shallow gravity well metal underfoot. Autonomous miners chew regolith, feed smelters, and spit mirrors by the acre. Railguns loft stacks of foil into parking orbits. Tugs knit them into sails. Sails become statites that feed the minds that made them. If you can replace mirrors faster than micrometeoroids and sabotage eat them, you can surge. Under doctrine, that's stamina. Under fear, that's mobilization. Kinetics don't go away, they just get repurposed. You can stockpile rods, slag bundles, and shepherded rocks in cislunar and Mars-crossing parking orbits. They're cheap momentum and terrifying headlines. Against directed energy, they're leverage, not victory. A well-phased beam ablates a flank to nudge trajectory or throws a plasma cushion that spreads the hit. Kinetics force choices. Beams force timing. The duel becomes, who makes the other spend their best tool on the cheaper problem? Beam shaping splits along air versus vacuum. In vacuum, coherence rules. You choose bands that couple to skins, near IR for structures, microwave for volatiles, and you ride clean geometry. Through air, you treat the atmosphere like a lens and a fuse. Certain bands slice through, others bloom into plasma. There's an ugly trick called skip-glide ablation. Hit a vehicle shallow so a plasma sheet forms and rides along the surface, spreading heat under coatings. Seams peel. Fast. That technique started as de-icing in a lab. It scales until ethics says stop. Planetary defense is the friendliest mask weaponization ever wears. Put mirror clusters on interceptors. Practice with asteroids. Gentle ablation to nudge spin, slow thrust to move impact points. The day a bus-sized rock aims at a city, you're a hero. The day an unauthorized tanker rises through your lane, the same playbook stabilizes a fuel line at the worst possible moment. The test for intent isn't the gadget. It's the schedule, the dwell, and who got a say. Let me give you a micro story. A Shaz team ran a disaster drill over the Pacific. A typhoon shredded a coastal grid, so they tightened phase and punched power through the rain to a hospital dome. Numbers climbed. Lives were saved. 2 months later, a decommissioned oil rig became a calibration target. Same phase tightening. Same wavelength shift to a band the spray loved. The rig erupted into a bouquet of steam and twisted steel. The console didn't change. A Shah wrote a note to herself. The line between help and harm is cadence. Local countermeasures live in boring bureaucracy. Cities can pre-authorize cloud seeding to raise absorption at your favorite band, forcing you to switch wavelengths and lose efficiency. Launch providers can rotate reflective blankets into view when sensors twitch, enough to harden for seconds while they tumble. Airspace rules can forbid high-precision beams through inhabited columns without consent, then bind consent to logged warm-ups that take long enough for people to object. Even the traffic lanes matter. If ascent corridors thread through mirror clusters with mandated keep-out zones, the power holder owns the pause button. Culture either builds brakes or it doesn't. Beam time can be sacred, logged, witnessed, audited, or treated like bandwidth, throttle as needed, hit your service level agreement. Insurers can demand redundant interlocks and payout clauses that triple if dwell exceeds caps. Militaries can carve rare exceptions that stop being rare. Treaties can try to draw lines. No beams within X seconds of a kinetic release. Maximum coherent aperture Y for operations near Z orbits. Mandatory thermal telemetry with hour-scale delay. Enforcement is shame until someone decides shame is expensive. The intersystem fight rewards people who love friction. Build hard caps into hardware. Physical aperture limits that can't phase beyond a set diameter without swapping modules under watch. Split keys for tight modes across adversarial institutions. Regulator, rival, public archive. Bake slow warm-ups into firmware so retask can't snap without lighting up heat ledgers. Publish schedules for drills so neighbors can subtract your rehearsals from their fear. If this sounds cumbersome, good. Cumbersome is a break you can audit. Of course, incentives nibble. Elections don't like blackouts. Launch windows don't wait for rituals. A heat wave doesn't care about your cap. This is where leadership either eats the cost or teaches the exception. The culture that survives chooses the cost. It keeps slow handovers during a crisis and takes the heat in the press. It forces emergency to mean public unlock with witnesses, not a token on one desk. The local fight isn't a fleet duel in deep space. It's 1,000 ordinary decisions that either normalize precision or normalize restraint. Under a dark sun, we don't get to choose whether control is powerful. We choose whether control is easy. If we keep it easy, doctrine will drift toward the switch that makes perfect sense in a storm and a mistake in a standoff. If we keep it hard, we might stay neighbors. Civilization psychology. Why we build weapons we don't admit. Path dependence starts small and looks harmless. You pick a control architecture because it meets the deadline, the budget likes modularity, and regulators are comfortable with one clean interface. That choice locks suppliers, software stacks, training paths. A few upgrade cycles later, the easiest way to add safety is to add control. The easiest way to add control is to centralize phase authority. Centralized phase authority isn't an optimization, it's a doctrine. Incentives aim the wrench. Utilities hate downtime, politicians hate brownouts, insurers hate ambiguity. So the control plane learns to promise certainty, guaranteed delivery windows, guaranteed coupling through storms, guaranteed retask after flares. Certainty demands sharper sensing, faster arbitration, more bypass paths. Now guaranteed quietly includes the ability to cut through anything that would spoil the guarantee. No memo says weaponize. The metrics do. Bureaucratic drift is patient. A safety exception enters as a temporary bypass. It stays because it saves money and embarrassment. Power caps gain emergency override. Geofences get maintenance corridors. Manual approvals get automated because the queue's too long. Before anyone votes, the fastest path is the override path. You didn't build a weapon. You removed frictions until only the blade was left. Deterrence adds a twist. If you want neighbors to respect your interlocks, you have to show you can ignore them. Demonstrations prove competence and normalize the mode. A calibration burn becomes a template. When a crisis hits, the practice path feels like the safe path, even when context changed. Deterrence eats doctrine from the inside out by rehearsing the thing you claim is last resort. Moral distance grows with automation. A human in the loop sounds comforting until the loop runs at machine speed. At swarm scale, the person approves policy, not shots. The dashboard shows green. Optimized coupling looks like virtue. The machine maps it to tighten spot. Intent gets laundered through abstractions. No one decides to harm. The system routes power, trims side lobes, maximizes absorption, and a hospital dome steams because an identifier collided. We've done this with every flow control system. Dams promised irrigation and flood control. Gates became levers in war. Civil GPS guided tractors. Permissions shifted and it guided munitions. Traffic algorithms eased commutes. Then a city learned it could freeze protest routes without a single baton. Control is value agnostic. It bends to the strongest incentive in the room. Culture tilts the board. We praise mastery, clean handovers, perfect phase, zero side lobes. Pride and precision assumes someone upstream handled why. The more capable the tool, the further ethics drifts from the hands that make it sing. That's not evil, it's competence. The antidote isn't ignorance. It's friction you can't wish away. So you weld friction into the build. Hard caps in hardware. Delays that can't be bypassed without public notice. Split keys for tight modes held by institutions that mistrust each other. Regulator, rival, public archive. Audit trails that are append only and mirrored abroad. Telemetry that flows to competitors so safety can't hide behind classification. Make the high-precision path expensive, visible, and slow on purpose. Then ritualize the breaks. Engineers roll their eyes at ceremony until ceremony is the only defense against drift. Mode changes need witnesses. Warm-ups include spoken constraints. Unlocks require quorum across jurisdictions with timed pauses that newsrooms can cover. Teach doctrine as engineering. Phase authority is policy. Retask speed is escalation. Side lobe suppression is collateral on a dial. Promote restraint alongside performance. Reward teams that held caps during a crunch. Asha learned how habits harden when her lab adopted a fast lane for emergency retask. Investors beamed at the latency numbers. Regulators nodded at the word emergency. In review, she asked who defined emergency and how the hardware would know. The answer was a token. Tokens multiply. She pushed for split keys and a warm-up timer that screamed in mid-IR anytime the lane opened. The timer cost a contract. It also kept their doctrine honest. Fear sells shortcuts. A blackout before an election. A launch window that won't wait. A storm over a hospital. Each one makes the exception feel noble. Exceptions accrete into defaults and defaults write doctrine. The only way to stop that slide is to love breaks as craft. Make restraint measurable, legible, and prestigious. There's a story we rarely tell. Modest cultures outlast ambitious ones not because they lack courage, but because they waste potential on purpose. They cap coherent aperture below hardware limits. They federate control so a snap retask can't happen without a ritual. They publish heat ledgers with delays short enough to matter. Their swarms hum instead of sing. Their engineers retire with pensions, not memoirs. Why do we build weapons we don't admit? Because the shortest path from promise to performance runs through control, and control is a blade. If we want a swarm that warms worlds, not erases them, we have to prove, daily, publicly, that our hands prefer breaks to sharpness when it costs. SETI under fire, listening without dying. If the sky rewards quiet, how do we listen without raising our hand? Start with discipline. No citywide radio floods. No omnidirectional pings that brag about day length in chemistry. Build a whisper strategy. Narrowband, low power, intermittent beacons that look like thermal noise unless you know the handshake. Transmit rarely, off axis from home, during cover. Eclipses, solar glare, meteor showers that spike natural noise. Favor wavelengths your star already leaks so your voice blends into its breath. Curiosity is fine. The geometry has to be careful. Reception flips the old dream. Classic SETI chased messages. Under a swarm-capable sky, signals are risky and industry is safer to read. Hunt technosignatures of work. waste heat rhythms, polarization that screams coherent surfaces, spectral lines from industrial chemistry, light curves that refuse astrophysical timing. You're not decoding poems, you're reading a shift schedule. That means mid-infrared patience, multi-year baselines, cadence analytics, and crossband correlation. Behavior over brightness, doctrine over drama. Protocols have to assume the dark forest is operational, not poetic. Set a do not reply default with long delays as policy, not panic. Any candidate goes to quarantine, offline storage, adversarial review, and attempts to kill the tech hypothesis before anyone reaches for a transmitter. Build delay lines measured in months or years. Let excitement cool. Survival can't reset if you guess wrong. If you ever respond, use displacement and indirection. Don't transmit from Earth. Route through a distant relay, an off-ecliptic probe, a solar gravitational lens node far from home, or a one-off laser sail that burns once and dies. Strip identity. No coordinates. No time stamps that reveal our day length. No spectral quirks that betray our air. Keep content minimal, acknowledgements, and simple tests of comprehension. You're seeing if something listens back, not handing them targeting data. Assume beacon traps exist. A signal that says safe channel here is exactly how you coax a noisy species into shouting. Traps exploit empathy and pride, prime numbers, almost familiar star maps, cultural bait. Counter with discipline. Treat every invitation as a hazard until independent analyses agree on natural alternatives being worse. The burden of proof isn't on fear, it's on certainty. Next, harden our own noise. Radar schedules shift to windows with cover, solar events, auroral spikes, so side lobes don't write our geometry into the sky. Laser comms get caps and sky exclusion cones during transits. Airports don't test pattern beacons during clear, quiet nights, they pick weather. Apply the same to space. Quiet by default, noisy under camouflage. That's not paranoia, it's hygiene in a crowded forest. Build red teams whose job is to break our favorite explanations. Give them veto power on claims. Train them on imposters, plasma lensing, scintillation, masers, glints, clock drift, processing artifacts, satellite constellations pretending to be lighthouses. Make every maybe survive hostile review before it becomes a headline or a trigger. Wishful thinking is a vulnerability. Skepticism is armor. Law has to grow teeth. Draft a standing no first reply compact with verification. Monitors that capture outgoing high-power transmissions and publish alerts. Audit trails for lab lasers and satellite downlinks. Penalties for rogue broadcasts. The point isn't censorship, it's custody. A single lab shouldn't be able to light a beacon for 1,000,000 years without anyone's consent. Transparency lowers misinterpretation risk. When we test power beaming, publish coordinates, times, and caps so neighbors can subtract our drills from their fear. Invite neutral monitors, international and even adversarial, to certify modes and dwell. Reciprocity where possible, unilateral restraint where it is. If we can't build trust, we can still build legibility. Hair trigger skies hate surprises. Reorient funding. Less megaphone, more microscope. Invest in mid-infrared cadence observatories that stare for years, not nights. Put sentinels off the ecliptic to watch regions our glare hides. Pair thermal eyes with polarization cameras and high-speed photometers tuned to catch phased array tweaks. Push analysis toward behavior. Are we seeing logistics or drills? Build public archives with raw and calibrated data so rivals can cross-check and learn the same caution. Then teach doctrine to the listeners. Observers need to understand beam physics, scheduler signatures, and what maximized coupling implies. They should recognize strike cadences, snap retasks, asynchronous radiator pulses, so a candidate gets tagged hazardous posture without theatrics. Engineers should learn listening ethics. Whispers only, delayed by default, relayed far from home, content minimized. Promotion should reward restraint, not just discovery. Ashaz Lab wrote its own protocol after the oil rig lesson. No high-precision emissions within 48 hours of any anomaly outside our atmosphere. No calibration burns aimed through inhabited air columns. Whisper tests only during solar glare, routed through a relay that dies afterward. Every unlock required split keys, the regulator, a rival lab, and a public archive stream that showed the warm-up timer in mid-AR. It was clumsy. It worked. They slept. Here's the gut check. If a narrowband line stares at us from a fixed point, don't assume friendship. Assume a lighthouse or a leak and treat it like weather until the heat proves a factory. If a broadband burst repeats with orbital cadence, weigh magnetars and tech together and don't publish a narrative until the cadence survives new data. Prize the null. A boring sky can be a safe sky. Listening without dying means loving three things: delay, indirection, and behavior. Delay buys time to think. Indirection hides home. Behavior turns mystery into logistics. If we're lucky, patience will teach us to read the quiet well enough to notice neighbors who survive the same temptations, and to prove in our own rhythms that we're here to learn, not to be scheduled. The cases that keep astronomers up. Tabby's star was the first all-nighter. In 2015, KIC 8,462,852 dimmed by 15%, then nearly 20%, in messy, irregular chunks no exoplanet could explain. Astronomers lined up the natural suspects: dust clumps, fragmented comets, debris from a shattered world. The infrared check mattered. No strong mid-IR excess that a hot, sloppy megastructure should spill. That pushed Dyson off the table for most, but the lesson was case closed. It was behavior over brightness. If someone ran cold and directional, you'd need rhythm, not just dimming, to call it industry. Fast radio bursts kept everyone honest. They're almost all natural, magnetars cracking and ringing like cosmic bells, but a handful of repeaters flirt with engineered cadence. A source ticks with seasonality. Polarization swings like someone twisting a dial. You don't jump to beacon, you test harder. Rotation measure changes fit a turbulent nebula, not a radiator farm. Still, FRBs taught a habit of mind. If you wanted to test a relay undercover, you'd hide in a band where nature already shouts. The point isn't that they're artificial. It's that camouflage has templates. Infrared sky maps promised clarity. WISE launched in 2009 and swept the sky in mid-IR, exactly where waste heat should glow. Teams flagged thousands of too warm stars. Most turned into dust, protoplanetary disks, red giants, carbon soot. That null is data. Bright, wasteful Dyson fantasies are rare nearby. It doesn't kill careful swarms. It narrows them into behavior space where cadence, correlation, and recovery time carry more truth than raw flux. Closer to home, we've got the ghosts we made ourselves. LaserCom glints off aging probes. Narrow monochromatic spikes in archive spectra that vanish when you point a second instrument. Most are sun glints or cosmic rays in detectors. A few persist for 3 frames at angles that argue against simple reflection. Classified tests muddy the pool. Hoaxes do too. The operational fix isn't romance, it's audit. If you can't certify your own glints, you'll never trust a neighbor's. Then there are the disciplined anomalies, the ones that survive the easy explanations. A main sequence star with a small, stubborn mid-IR excess that drifts over months. The drift doesn't track known dust maps. Photometry shows shallow, non-planetary dips that don't lock to a single period but walk across inclinations like a rehearsal. Spectroscopy stays clean. No outgassing lines. You write non-astrophysical periodicity candidate, not weapon drill, and you invite demolition. Some get demolished. A few sit for years, haunting the inbox. Tabby's star left us a checklist. During dips, does color redden like dust or stay gray like opaque structure? Before and after, do thermal bands bump as you'd expect if someone masked light and then dumped waste? Do the timescales match dust orbit physics or station-kept geometry? That discipline moved the field. Odd light curves don't trigger megastructure headlines anymore. They trigger battery after battery of falsification tests until the big idea is the last one standing. Asha lives in those edge cases. Her team watches a mid-IR source that's boring in brightness and interesting in rhythm. Every 73 hours, 3 patches in different orbital planes warm by a fraction of a Kelvin, one after another, each pulse offset by 11 minutes. 2 weeks later, the offsets flip order. There's no matching stellar activity, no dust transient on the maps. It could be an instrument quirk. It could be a binary breathing through a weird envelope. Or it could be something practicing handoffs. A shaft files it as cadence candidate, then sits on her hands for a year because patience is part of not writing someone else's schedule. FRB catalogs added another puzzle, a repeater whose burst arrival times clustered around a 16.35-day cycle. Magnetar models fit, with precession and wind interactions, but analysts still asked doctrine questions. If a relay wanted to stay invisible, it could ride a natural sources window so your model kept blaming weather. The counter is diversity. Watch in bands magnetars don't favor and look for crossband tells, tiny thermal blips that hold phase with the radio ticks. So far, nature keeps winning. That's good. It trains the muscle we'll need if a non-natural cadence ever refuses to break. WISE's nulls pushed observers into behavior-centric surveys. Instead of too much heat, they hunt wrong kind of heat. In clusters, a handful of stars deviate from the dust law in the same odd way. In wide binaries, one component breathes thermally with seasons that don't match the others. Most collapse under better calibration. Some don't. Those become dossiers, names, coordinates, cadence plots, crossband overlays, and a plan to stare across winters without telling a story out loud. Ground truth matters. A lunar far-side station could pin mid-IR variations without Earth's atmosphere flicker. Off-ecliptic sentinels could watch through the zodiacal glow that blinds us now. Put polarization cameras next to thermal eyes to catch coherent surfaces when radiators roll. Build archives that keep the raw and the reduced. Let rivals, friends and not, try to break your favorite candidate before your ego does. The cases that keep people up aren't smoking guns. Their behavior at the edge of our models, rhythms that look like schedules, heat that acts like logistics, cadences that survive new instruments. The sober path is the same path that keeps us alive. Assume nature until it hurts. Assume doctrine only when behavior stacks. And if you think you're seeing practice, don't become part of the drill by shouting. The human build, roadmap to a swarm. If we walk this path, it won't begin with a Dyson anything. It starts with work that pays its own bills. First comes power from orbit the way engineers actually ship it. Kilometer-class solar platforms in geosynchronous orbit beaming microwaves to rectennas on the ground. You pick industrial ISM bands around 2.45 or 5.8 gigahertz because they're understood and predictable. You learn phased array discipline not in a lab, but by feeding ports, islands, and disaster zones that complain when lights flicker. Every smooth handover is training. Every outage is a lesson in humility you can't fake. Clusters beat single birds. One satellite hands to another, then to 10. Laser links knit a metrology spine, optical clocks that agree to picoseconds, inter-satellite beams that measure path length to fractions of a wavelength. Phase lock across tens of kilometers, then hundreds. The control stack grows up. Mesh routing, voting logic, fault containment that degrades gracefully instead of catastrophically. You publish beam schedules and logs because regulators demand it, and because transparency is a break in disguise. The rhetoric is resilience. The truth is habit. Lasers arrive next, not as weapons, but as lifelines. You beam power to high-altitude platforms, airships, stratospheric relays, drones, and you discover what humidity, aerosols, and turbulence do to coherence. You learn to pick wavelengths like a mechanic picks sockets. Near IR here, shortwave there, polarization when the air lets you get away with it. Maximize coupling becomes a craft. You document what coatings drink, what surfaces shrug, and how dwell turns help into harm if you forget the timer. That library will be useful later, for reasons you'd rather not need. Then the industrial step, Mercury. The 2010s taught us how small, cheap probes could map and mine. Scale that mindset. Mercury's sunlight is 4 times Earth's, its gravity well is friendly, and the regolith is ore waiting for a refinery. Autonomous miners chew, smelters spit, printers lay mirrors thin as leaves. Railguns and tethers loft stacks to parking orbits. Tugs stitch them into sails. Sails become statites. The loop closes when statites beam power back to the minds that built them. Replacement rates move from aspiration to routine. If you can outpace micrometeoroids in peacetime, you've built stamina for everything else. Autonomy isn't optional. No one steers 100,000 nodes by hand. Local clusters reach consensus on phase and health. They surface intent, point here, dwell this long, stop if you see ex-humans approve policy, not shots. That's where governance has to get ahead of drift. You weld breaks into silicon. Hard caps on coherent aperture. Warm-up timers that physically cannot ramp faster than a treaty allows. Tight modes locked behind split keys held by institutions that don't love each other. A regulator, a rival, and a public archive that streams unlocks with hour-scale delay. A kill switch isn't off. It's revert to diffuse, revoke phase authority, fall to maintenance patterns that can't cohere, and open logs. It needs independent power and adversarial code written by a team paid to think like a saboteur. You assume the main control plane will learn to route around breaks unless the break enforces physics. Fuses that blow if a beam sharpens past a threshold. Physical interlocks on baseline geometry. If that sounds old-fashioned, good. Old-fashioned survives panic. Treaties without telemetry are theater. You get numbers instruments can check. Maximum coherent aperture, minimum ramp time, maximum dwell per region, retask rates capped by design. You publish schedules for drills. You let neutral monitors park sensors where they can see your radiators breathe and certify you stayed inside your envelope. Reciprocity where you can get it. Unilateral restraint when you can't. If a neighbor won't open their logs, you tighten your caps and say why. Legibility beats trust when trust is scarce. Industry becomes quiet arms race. Spares on the Moon, Mercury, and cislunar depots. Coatings cached in different jurisdictions. Actuators, clocks, and radiators sourced from suppliers that can't all be squeezed at once. You plan to replace a couple percent of your mirrors yearly at peace and surge to 10% under stress. Logistics is morality here. A supply chain that survives fear is the only deterrence that doesn't tempt you to cut corners when the grid aches. Culture carries the load law can't. You teach engineers doctrine as part of craft. Every meter of phase stability is escalation on a slider. Side lobe suppression is collateral on a dial. Retask speed is a promise you might not want your grandchildren to inherit. Make restraint prestigious. Promotions for teams that kept caps during storms. Public ceremonies that make unlocks feel heavy. Witnesses, spoken constraints, warm-up timers you can see in mid-IR. Rituals don't fight physics. They fight drift. A Shaz lab did it the slow way. They built a fast lane they refused to use without a quorum. The regulator's key, a rival's key, and a live feed that showed the ramp like a sunrise in thermal. Investors grumbled. A contract slipped. After the oil rig incident, those same investors stopped asking for demonstrations and started asking for proof the brakes worked. The proof was a blackout they could have prevented in seconds. They let the timer run. The hospital lived with batteries and backup generators. The city cursed. The logs sang restraint. This is the roadmap stripped of romance. GEO clusters to get good at phase. Laser beaming to learn coupling in air. Mercury to print mirrors until replacement rates feel boring. Autonomy with breaks in hardware, not promises in memos. Telemetry you share so rivals can subtract your drills from their fear. A culture that loves friction when elegance would be easier. If we're lucky, we'll build a swarm that hums, not sings, and we'll prove every day that our settings file prefers life. Ethics under the dark sun. Silence feels like surrender until you count what it prevents. Under a dark sun, ethics starts with irreversibility. A broadcast you can't recall, a cadence you can't unteach, a swarm that can't forget how to aim. Curiosity has dignity. So does survival. The hard part is designing a life where those two aren't constantly pulling each other off a cliff. Begin with consent. Steering power through inhabited skies changes people's risk without their permission. If ethics means anything here, it means no precision without collective assent. Subsidiarity helps. Keep decisions as local as the harms. A municipal array can tighten within posted caps. A multiplane lattice touching 3 worlds can't sharpen without an interplanetary quorum.